Today is 20th of June 2013. Today we're having a look at this interesting picture and a discussion about how bright the moon is. I first found this image in a discussion about how bright the moon is when we were looking at perception of colour and contrast. I'm going to come back to this image in a little while. We'll take another look at it. But first of all, the question is sometimes asked, how bright is the moon? What we're talking about there is the reflectivity of the moon's surface. This is called albedo. And as we can see here, the different planets and the moon have different albedos or reflectivity. The brightness is Venus with an albedo of 0.65. As it says here, this means that 65% of incoming sunlight is reflected from the cloud-covered planet. The remaining 35% contributes to the heat energy of Venus. Mercury at 0.11 has the lowest planetary albedo. Now the albedo of the moon is given as 0.12, as we see here. I've checked this in a number of different sources, and they all seem to agree that the moon's albedo is around about 0.12 on average. Of course, that does depend on a number of factors, including the area that you're looking at, the phase of the moon, the angle of the sun, and so forth. But on average, the albedo is 0.12. Now, there have been some claims made that the moon is actually as bright or as reflective as coal, which is interesting. Now coal, there are a number of sources, number of websites and so on that say that coal has an albedo of 0.1, which obviously is very close to the moon's average albedo of 0.12. I've also seen contradicting claims that coal actually has an albedo of 0.04 or thereabouts, but again it depends on a number of factors, depends on the grade of coal and other factors. But anyway, let's go back to this picture that we're looking at. Now clearly square A in this picture is a lot darker than square B, isn't it? Well, is it? Let's take a closer look. Certainly to my eyes it looks like B is much brighter, much lighter colour or a shade than square A. But let's have a look. This is opened in Windows Paint. So what I'm going to do is just cut out a little square, just select the area here and copy and paste. So here's a direct copy of what I've just cut out there. We can see it's exactly the same shade, and again it certainly looks like it's darker than square B. I'm just going to stretch this out a bit, and again it's the same as what we started with. There's no trickery here. I'm going to move it around, put it down here, and it still looks very dark. Move it over here. Let's go back to where I was, back up here. Now let's move it down slowly to square B and see what happens. Well, look at that. It's the same shade. No trickery here. This is just paint, and you can try this yourself. In fact, I'll put a link in the description area so that you can find this image and you can play around with it yourself and see if this is true, because certainly to my eyes it looks like square A is darker than square B. But we can see, if I put them like that, we can see that the shade is contiguous through there. It's exactly the same shade all the way through. Yet if I undo that and paste again, it certainly looks like A is darker than B. And let's move this over here as well. This is an interesting little thing. Is out here on the right hand side of the green cylinder, again square A looks very dark, but as I move it across into the shaded area of the green cylinder, again it looks brighter. So again I'll paste the one that we copied from square A, same shade, and place them side by side, and I would swear that the square on the right hand side here is darker than the one on the left hand side. But as we've already proven, they're actually exactly the same shade. It actually looks like it's sort of blending in there from the right hand side, doesn't it? But they are in fact the same shade. So that's an interesting thing. Certainly the albedo of the moon is 0.12. It is very dark. I'll put some links in the description area so that you can do some more reading on that if you want, but I just thought that this was a fun sort of thing to have a look at. It's interesting how our eyes can play tricks on us, and this is certainly a very interesting one. So Thanks for watching. As always, check out my Facebook discussion page, Voices of Reason to Explain X or Vortex, and I'll put a link in the description area for you. Thank you. Hello YouTube, this is Dazza the cameraman, and today is 20th of June 2013. Today we're having a look at this interesting picture and a discussion about how bright the moon is. I first found this image in a discussion about how bright the moon is when we were looking at perception of colour and contrast. I'm going to come back to this image in a little while. We'll take another look at it. But first of all, the question is sometimes asked, how bright is the moon? What we're talking about there is the reflectivity of the moon's surface. This is called albedo. And as we can see here, the different planets and the moon have different albedos or reflectivity. The brightness is